right, part 2. I think I was stumbling through trying to give you a visual on fracture zones and the transform faults that occur along those. So main thing, remember that transform faults are perpendicular to the mid-ocean ridge and reduce that stress. And they can extend for thousands of kilometers, and that's where we find our earthquakes, shallow earthquakes. Then we have seamounts, gyos, and aseismic ridges. This is a seamount, and it's a conical undersea mountain that rises greater than 1,000 meters above the seafloor. Once that's eroded and kind of gotten flat-topped by wave action, it's called a gyo. And an aseismic ridge are chains of seamounts not associated with earthquakes. Whoops. All right, I forgot my little pointer thing in case I need it. Reefs are wave-resistant ridges of coral, algae, and other calcareous organisms. They form in warm, shallow, sunlit waters, places that we'd like to be right now, like off the coast of Australia or perhaps Hawaii, places like that. So a fringing reef is a reef that is encircles an island right along and next to that island, basically attached. And then a barrier reef is a reef off the shore of the island, and it parallels the coastline. And then an atoll is a rim of reef that is has a lagoon in the middle. So those are the different types of reefs. All of them would be wonderful right about now. All right, so heterogeneous sediments are sediments that are derived from land that end up on the ocean floor. They're basically found along the continental rise and the abyssal plains. And then pelagic sediments settle slowly through the ocean water and are derived from very, very fine clay and delivered primarily by wind because it's so fine and it's able to get out into those deeper oceans. And we also have skeletons of microscopic organisms. So these are nearly absent on mid-oceanic ridgecrest because they're so new. It takes time for that fine material to accumulate over long periods of time. Oceanic crust is about 7 kilometers thick. And there's different, you can kind of see the different layers that form. Pillow basalts are these kind of rounded basalts. When you see a pillow basalt, you know that it formed underwater. If you're over in the Morro Bay area, there's some good examples along the beaches there of some pillow basalts. And then ophiolites are rock sequences that formed in the ocean that are now on mountaintops on continents. So those are pretty cool and of interest to geologists because we don't have to go underwater to study them. The age of the seafloor. All of the rocks and sediments of the seafloor are less than 200 million years old. Important to remember. The seafloor is very, very young in relationship to the rest of the continental crust, which preserves rocks up to about 4 billion years old. Seafloor and plate tectonics we'll get into next chapter. We won't spend any time really on that other than, we're actually just going to wait. So hopefully that helps. This part was short, and we'll jump into plate tectonics here. You guys, if you have any questions, let me know, and I hope you're all doing well.